Hey guys, can you believe it? We are down to two more lessons this entire year. That's two more chances to see me in all my glory, um, making videos for you. So that's kind of cool. We're almost there. You almost made it. Um, but let's make sure we finish strong. And this today's gonna be a little bit different because this topic I want to go over is not in your book. And so that's going to be a little bit tricky. This is one of those cases where, in my opinion, books, but maybe not the best textbook I've ever seen. We talked before about this idea of arithmetic of functions and how you can add, subtract, multiply. You can actually divide functions as well, though we didn't get into it. But this process I'm going to show you today is pretty different. It sort of is a nice continuation of that thought, and certainly I think will make more sense once I get done. But I just want to warn you, this is not in your book. So your assignments for this week are all going to be worksheets. Again, you're going to pick one of the three, but you're not going to find this in your book. Okay, let me switch over. I'm going to be switching back and forth quite a bit right here, but let me start with this picture right here. And my wife made these. This is what she does. She makes wedding cakes, but she also makes cupcakes for weddings. So there's some like raspberries on top that's like a raspberry filling inside the vanilla. There's a caramel, like a salted caramel one there. There's an Oreo. I can't see those little tiny Oreos there on top of like an Oreo frosting. Then there's I think the last one was a red velvet. So this is for a wedding that happened last summer, I guess. Anyway, so my wife is a baker, and I want you to sort of think about the process that she would go through to create this. Now, it is just her when she does this, but I want you to imagine for a second that she had three people on her team, and each person had their own set of duties. And we're going to walk through those duties one by one, okay? So the first person has this duty. They have to take all the raw ingredients, the eggs, the flour, the butter, the sugar, maybe some salt, whatever, mix it all together and make batter. Maybe, you know, even fill the little cupcake tins with cupcake batter. That's baker number one, okay? Baker number two's job is to take those already filled muffin tins, put them in the oven. And you might be thinking, how hard can it be to bake something? Well, if you bake, you know, you got to keep an eye on things and make sure that you do it for the right amount of time, that it's not too hot, temperature's not too low, you take them out, everything's good to go. So the baker actually does the baking, takes the batter, puts it in the oven, takes them out, and then the third person gets them and does their fancy decorations. Okay, so you know, they're the ones that get a lot of the attention because they're the ones that make the cupcakes look so pretty. But if the first two don't do their job, you don't have anything. And you end up with this beautiful display here of cupcakes for a wedding. So I'm going to talk through just for a minute here how this process works. Because if it's not done properly, bad things happen. So let me go back to the whiteboard now. And again, just to be clear, the title of this subject is composite functions, or the composition of functions. So let's take a look at this in order. We have baker number one. What was baker one's job to do? Mix ingredients. And fill cupcake tins. Okay? And so what happens is that baker then takes these completed cupcake tins and sends them along to baker number 2. Now, baker number 2 doesn't know anything about mixing ingredients. Probably they do. But in this case, they don't know anything about mixing ingredients. All I know is they're going to receive these cupcake tins filled with batter. Their job, put cupcakes. Whoa. Spell much? Seems kind of simple. Put cupcakes in the oven. Take cupcakes out. That's all they got to do. So they receive the cupcakes on one end, put them in the oven, and they take cupcakes out. Then they hand off their cupcakes to the third baker. And again, in keeping with this line of thinking, the third baker is the one that's going to decorate, right? So the third baker is the decorator. Okay. But the third baker doesn't, like, bear with me, doesn't know anything about mixing ingredients, doesn't know anything about filling cupcake tins, doesn't know anything about baking, but this decorator is really, really good. And that's not terribly unusual, by the way. If you ever watch a show like, I don't know, The Cake Boss or something like that, they don't really talk about this, but they've got certain people who just bake all the cakes, that they're really good bakers. Then they hire other people to be decorators. All they do is they decorate. So I want you to just imagine for a second, what would happen if they did these things out of order? Like, what would happen if baker number 3 decorated all the raw eggs, the flour, the butter, put all their fancy frosting on top of the stick of butter, and then put it all in the oven, and baker 2 baked it all. Man, I guess just raw eggs, flour, and then baker 1 decided all these baked, decorated things, now I'm going to start mixing them all up. There's no way it would look like that fancy table that you saw there of cupcakes. Or what if we baked everything first, like bake the raw eggs, bake the butter, bake the flour, then decorate it all, and then mix it all up. Like, it doesn't work if you do these out of order, right? Baker 1 has to go first, taking all these ingredients in as input, doing what baker 1 does, and then as output, sending out the full cupcake tins to baker number 2. Baker number 2 has to receive all these full cupcake tins as input, bake them correctly, and then pass them along to baker number 3 as output. And baker number 3 takes these bare baked but bare cupcakes in, decorates them all, then they look all pretty, and then sends them off to the wedding. So there's this process of taking something as input, performing some function, and then providing them as output. So why am I talking about baking other than cupcakes are delicious? It's because that concept is exactly at the heart of what we're going to look at today, which is composite or composition of functions. Okay. So I'm going to give you a new notation now. It's going to look like this. And hang on, this is kind of crazy. It's going to look like f of g of x. F of g of x, also written as, and that is not the letter O, although people like to call it fog. That open circle represents composition. So that's weird notation. Remember we had f plus g, f minus g, and f times g before. That is a closed dot right there. That is an open dot right there. So there is a difference. So let's talk about what f of g of x means. I'm going to just sort of say this many times. Order matters. If you remember back to the baking example, you got to mix the ingredients before you can bake the ingredients. And you got to bake the cupcakes before you can decorate the cupcakes. So order matters. In this particular example, g of x gets applied first. It's the first function. It's the one closest, g is the one closest to the x. So g goes first when written like that. And only after g is done does f get a crack at something. Okay, so g first, then f. And it's a little bit confusing, so let me give you a quick example here. Let's let f of x, and I think we'll use this example a few times here. F of x equals x plus 3. By now, you should know what that means. That means the f function is to take any number you give it and add 3. You give it 7, it's going to put out 10. You give it 13, it's going to put out 16. Give it minus 2, it's going to put out plus 1. Whatever you give it, it's going to add 3 and then spew it out. G of x is x squared, which means any number you give it, it's going to square it and give it out as output. So what I'd like to pose to you first, and I'm going to try to take this plenty slow here. Again, this is not in your book, so you're not going to have a lot of examples to work off of. So this is going to be it in terms of your examples. What does f of g of x look like? Well, we know that g of x is x squared. So I can replace this with x squared and then find f of x squared. Okay, so g of x is x squared. I just replaced it. And now I want to apply function f, not to the number 7, not to the number 13, not to the number minus 2, but to this expression x squared. What does f do to everything it gets? It takes that thing and adds 3. This is the input, and then it adds 3. So we say f of g of x equals x squared plus 3. So let's try this before we get too far in this. Let's try this with an actual number, because I think it can be a little bit confusing. So officially, this is May 26th, although you might be doing this some other day. So I'm going to let x equal 26, and I want to find f of g of 26. Okay? So we're not going to be dealing with x's anymore. We're dealing with just numbers. So let's go through this again. What is g of 26? G of 26, what does g do? Whatever number you give g, it's going to square it. So g of x is going to be 26 squared, which comes out to be 676. Cool. Now we're going to apply that to f. This is like, let me just clarify. This right here is like Baker 1. He's got everything mixed up, everything in the muffin tins. And then we're going to pass those muffin tins, also known as the number 676, off to Baker number 2. And Baker number 2 simply adds 3 to whatever it gets. So we say f of g of 26, 679. And here's what's kind of interesting. I think this is worth noting. Watch. If I just did this instead, look what would happen if I applied f of g of 26. It would simply be 26 squared plus 3, right? Because x is 26. But 26 squared is 676. See this right there? This is 676 plus 3, and in fact, it's 679. So there's two ways you can actually do these problems. You can do the function version of it, which gets you to something like x squared plus 3, or you can do the numerical part of it, which lets you work with numbers. Whew, what do you think? Let's try another example, okay? I have another set of problems. Let's try f of x equals 2x minus 1, and g of x equals 5x plus 3. And I'd like you to find f of g of x, and then f of g of 3. You can do that any way you want. What I'm going to encourage you to do right now is pause the video, try this. You can back up and look at the last example if you want. Try this, get your answers, and then you can start the video up again and you can see how you did. Okay? So I'll give you a few minutes to work on that. And when you're ready to start again, I'll be here. Okay, what did you come up with in terms of f of g of x? We know that g of x is 2x minus 1, right? Oh, no, excuse me. What am I thinking? G of x is 5x plus 3 over here. So now that's going to become, that's like the, let's move on. It's like the baked cupcakes being passed off to the decorator. And the decorator takes that as if it were the x in that function, and it does this to it. Watch. This goes right in there. This is one of the hardest concepts to get the hang of when you're first doing this. But you know, it's the last week in May of the year of algebra. You can do this. So this becomes 5x plus 3. And then we distribute. We get 10x plus 6 minus 1 is 10x plus 5. So f of g of x equals 10x plus 5. How'd you do? Yeah. Well, let's look and see what it might look like on this side on the right. Now, I have a thought here. If x is going to be 3, I could just kind of in my mind plug in 3 right there. 10 times 3 is 30. 30 plus 5, I think it's going to be 35. But I'm not going to do it sort of that shortcut way. I'm going to walk through the process here. G of 3, so I know I'm going to F eventually. G of 3 is 5 times 3 plus 3, right? If that's x, if x is 3, I just replace x with 3. 5 times 3 is 15, plus 3 is 18. So G of 3 is 18. Now I want to find f of that. What's the f function? Well, f takes whatever you give it. Whoops. F takes whatever you give it, multiplies it by 2, and subtracts 1. So that's going to go right there into 18. That's 36 minus 1. Lo and behold, look at that. It's 35. So we can do it from a function perspective here on the left-hand side, or we can do it from a numerical perspective on the right-hand side. Now, there is one thing I want to show you here, and it's a little bit, I guess, unexpected, but if we go back a couple pages, you might remember that in my first example, f of g of x came out to x squared plus 3. So let me write this out here. Whoops. F of g of x, this is my first example, came out to be x squared plus 3. Okay, this was, I'll put it up here, first example. First. Okay. Now, what I'm curious to know is whether you think this will equal that or not. Remember, this is this concept of commutativity, where we could we were able to add functions in any order we wanted, but we couldn't subtract them. Remember, that was a different result. We could multiply in any order. I will tell you that you can't divide in any order. So some operations work, or we say they're closed under commutative property, some are not. And the question is composition closed under the commutative property? Well, let's find out. What's f of x? By the way, I'm going to apply g to whatever that is. F of x was x plus 3, and g of x is x squared. Remember that? So f of x is going to be x plus 3. F of x, x plus 3. And now what does g do? G takes whatever it gets, and squares it. So the question is, are these two the same? And you better say no. Remember, this is x plus 3 and x plus 3. We do our FOIL. We get x squared plus 6x plus 9. Those are not the same thing. So in almost every case, f of g of x does not equal g. Okay. So what I'm going to want you to do is be able to use the function approach to figure out what, say, f of g of x is, or g of f of x, or even, oh, you want to see this? Watch this. Watch this. What is g of x? You're like, what? That's not g squared. That is, do g of x first, and then g it again, right? So g of x is x squared. So this right here is x squared. Then I'm going to g that. But what does g do? It squares whatever it gets. So this is going to be x squared squared, which is x to the 4th. So g of x, in this case, is x to the 4th. So you can do all kinds of crazy stuff with multiple functions, the function on itself, function with a different function. I'm not trying to just blow you out of the water here. We'll have plenty of time for that in Algebra 2. But for now, I want you to be able to find things like f of g of x, g of f of x, and so on, and then also do it for numbers. So your 3 options this week, again, are all going to be worksheets because it's not your book. First one, I'm going to call worksheet 1. I'm going to do questions 1 through 10. Option 2. It's going to be called the composition function worksheet. It'll be pretty, I'll make sure I label them in the same way. And that's 1 through 10 on that one. And then the third option, if you're thinking you're going to get less than 10 problems, you're not. They're all going to be 10 problems. Is just composition worksheet. And this you're going to pick 5 from section 1. Oops. Section 1. And then pick 5 from section 2. Okay, so a short week this week. You're getting this on Tuesday. This is still due Friday, May 29th. Okay, and I will see you back next week for the last time this year. Stay healthy, keep washing hands, keep doing your math. See you next time.